guys, about last video we know the principle of STP and we know some basic configuration of the STP. Now we have a practice. About this part, we will talk something about the application scenario of STP and also we will use a detail command to finish the practice. For example, we can change the bridge priority. Then we can have influence to select a root bridge. And we also can change the cost value or the port priority to have a limit to select the rules of STP. Who will become the RP, who will become the DP, and finally who will be blocking. And about the last, after we finish the configuration, which command can be used to check the result? That part of this video. Let's do the practice now.
Hello guys, this video we will talk something about the STP lab guide. And like this topology, now if we have 4 switches connect with each other, and you will find in this topology there are lots of loops, right? Between switch 1 and switch 2, we directly to use 2 links to connect with each other. There is a loop. And there also have some loop between switch 1 to 3, 1 to 4. So we want to deploy the STP in our network to prevent the loop. And about this lab, the purpose, first we have to understand and the master working principle of STP. And we have to master how to change the bridge priority and how to change the port cost value, port priority, and after we do the configuration, how to check the result. So there are the purpose. And about this lab requirement, first we have to specify switch 1 as the STP root bridge and the switch 2 as the backup root bridge. So we can directly change the priority. We can change the cost value of the port interface of the switch 4 and to manually select the root port. And also about the other switches, we also can change the root port. And about the configuration idles, we have to enable the Spanish tree at first and manually change the parameters one by one. And then let's see the detail process. First, we have to enable the Spanish tree, right? And now we already use the simulator and use the cable to connect with each other. And now the indicator is green. That means all the devices already start. Pay attention in your real network. If your devices now is not enable STP by default, suggest to start the devices one by one, not one click all the devices start. Maybe they will have the broadcast stop. So now if we start successfully, then we can do the configuration one by one. Right click to choose web console. And then we can enable to set the password and try to click OK and enter the configuration command. And now we can change the name at first to become. You can change the name to become Ruijie switch 1 or directly to use switch 1. SW1. OK, successfully. We have to enable the Spanish tree at first, right? The command is Spanish tree. If you forget the command, you can use a question. And directly enter to enable the function. And then we have to choose the mode to become STP. To become STP. By default, some scenario, maybe you enable successfully and the default mode will become MSTP. Depends on your real device. So this is a basic configuration of switch 1. The same command you have to add one by one of all the switches to enable the Spanish tree, the STP protocol at first. Also enable status password. Okay, config T. Change the host name to become switch 2. Spanish tree enable and the Spanish tree the mode to become STP. This is a warning. When you do the command here and then maybe there are lots of warning and you can directly continue to add the command. It doesn't matter. Otherwise, maybe you can wait until the warning is stopped and then you do the command, the same result. And the same one of switch 3. Enable password to become 123, Ruijie 123, config T, and change the name to become switch 3. And you have to enable the Spanish tree to select the mode to become STP. Okay, it's successful. You will find if you enable on switch 3 and we will do the recalculation again, right? Also the same with switch 1. So now if you enable the switch 4, Ruijie 123, Ruijie 123 dot config T, change the host name to become switch 4 and Spanish tree and Spanish tree's mode to become STP. Okay, so now they already do the calculation by use STP BPDO. If you use Wireshark to guess the packets, you can see the BPDO. And here you will say we receive the TC BPDO because now you change the topology, right? And our requirement is we hope the switch 1 can become the root bridge and the switch 2 is backup root bridge. So we can change the priority of the switch. For example, about switch 1, the Spanish tree priority is 4096. And about the Spanish tree 2, you will find if you change the parameters, we will calculate again. So this is the big problem in your real network because when you calculate successfully and you have to wait the interface to become forwarding status, then the user message can be forwarded out. But here we only do the lab practice guide. It doesn't matter. And about the Spanish tree, on the switch 2, we also can change the priority to become 8192. Okay. So this is a basic configuration here. Then you can check the result. Change the priority. And on the switch 1, you can check the result of show Spanish tree summary. Here you will find the root ID priority is 4096. What's the address? And here switch 1 is a root bridge. And what's the time? And the bridge ID information is same with the root bridge because switch 1 is a root bridge. And compare with the practice guide. About the MAC address, the parameter is different, right? Because each device's the MAC address is unique. So depends on your real devices. But the same should be root ID and bridge ID is same in the switch 1. Okay. And about the switch 2, we also can use a command show spanning tree summary. Okay, you will find the root bridge ID priority is 1496 and the MAC address is same with switch 1. And it will show you the MAC address is the root. This MAC address will become the root bridge. But here, the bridge ID information is the STP priority and the MAC address of switch 2. You will find the MAC address is different, right? So this is a command to check the priority, check the MAC address of these devices. So this is a result. And of course, use this command, you also can find what's the result now with all the switches, the interface. Like the switch 2, the 00 is a root bridge, and the 01 is another link connected with switch 1 is the AP, and the rest 2 interface will become the DP. Okay. So now we want to change the cost value of each interface on switch 4 and make the interface of gigabit 01 to become root port. And now we can check the result at first. Show spanning tree summary here. Now about the switch 4, who is a root bridge? Who is a root port? Our root port is gigabit 0/2 directly connected with switch 1. This is a root port, right? And now we hope we can change the port priority and finally to make the other interface gigabit 0/1 and this interface to become the root port. And here also show you how to select a root port. This is a principle. If you forgot, maybe you can see the detailed video before, or maybe you can see the detailed words here. And how to change it. This is a result, right? How to change it? We can directly enter the interface. Enter gigabit 02. And we can change the spanning tree, the cost value to become 4001. And pay attention, by default the cost value is 20,000, right? How to make the gigabit 01 to become a root port? One way you can reduce the cost value of gigabit 0/1, or another way you can make the other interface the cost value bigger. And then here we choose the second solution. We make the gigabit 0/2 to cost value to become 40001. Enter. Yes. Okay. And we will do the calculation again. And here we will use the same command to check the result. Exist show spanning tree summary. And now you will find the gigabit 0/1 to become a new root port. And about the gigabit 02, the state will become alternate in the blocking status, and the cost value will become this one. Okay, so this is a result to check the interface. Because now you change the parameters and the interface rule is changed. So we will send out or maybe receive some TC/BPO message on different interface to calculate the message again. Okay, and the fourth one, we hope to change the priority of gigabit 01 of switch 1 and makes gigabit 01 of switch 2 to become the root port. So about the switch 2, we can show the result. Show spanner tree summary. You will find now who is the root port. Is 0, 0, right? 0, 0 is the root port because the port number ID is smaller. And now if you want to change the gigabit 01 to become root port, you also can change the cost value or maybe change the priority of the interface. Also can have the same result. And how to change the priority? We can change on the switch 1. Enter the interface gigabit 01 and then the command is lost on the practice guide. In spanner tree, you can direct it to change the port priority here to become, for example, less than 128 to become maybe, you can see the suggestion of 16, right? Then come back to see the result of switch 2. You will find now this interface will become the new root port and the 00 will be broken. So here is the command, how to change the parameters on the network. And the key point of the lab, pay attention to the bridge priority and port priority. We have some limitation. About the bridge priority must be an integrated multiple of 4096. You can make the value to become 4096 or maybe to become 0. You cannot make to become 1, 2, 3, 4, something like this. And also the same limitation of the port priority. You have to make to become integer multiple of 16. So this is a limitation. And in your real network, you can add more terminals in the network. For example, connect with switch 3 and switch 4 and ping all the time. And then you can stop one maybe forwarding interface and to let the backup interface to become forwarding status. And you can test how long time we will discuss the message. Okay, so this is the result of the STP lab guide. If you have the same scenario, you can do the practice according to the lab guide. Thank you.